In this video, we'll be diving into advanced queries, using some powerful keywords like between, having, union, and joins. For each, we'll go in depth and provide examples. So let's get started. Last time, basic select statements were outlined and the syntax of SQL. Now, taking a look at price, we can select all between a particular price range. Here we'll do 10 and 22. As well as looking between values, we can look at everything not between two values. Between statements also apply to dates, however, they must be structured with a dash in the middle of each number. Having and where are often confused, but they do serve different purposes. Having was added to SQL because where cannot be used within aggregate functions. For example, let's take a look at a list of the number of customers in each country. Let's group it by country, except this time, having count of customer ID greater than 10. And we'll order that by customer ID. Union. You can see here my notations to explain that union means we'll select and combine two or more select statements. However, union does not allow duplicates. For this, you must type union all. So here, we're selecting city from customers and city from suppliers, and we want to combine those two data tables. We'll give you all the cities. Here we've got 91. And city from suppliers will give you 29. 91 plus 29, of course, being 120. When we type in the union statement to combine these tables, you note there's 94 and not 120. That's because this does not include duplicate values. Let's change that to union all. Joins. Now, joins warrant their own video entirely, but we'll try and fit it in here. It's one of the things most beginners and advanced SQL users are confused by, so let's try and make sense of it. Now, SQL joins are used to combine data from two or more tables in a database, similar to union, except not one on top of each other. They allow you to create a single result set that includes information from both the tables. The basic idea here is that you join your tables together based on a common column. For example, you might have a table of customers and a table of orders, and you want to create a report that shows which customers have placed which orders. Now, there are several types of joins you can use, such as inner join or just join, which is the default. This will only return rows with matching values in both tables. Left join will return all the rows from the first table and matching rows from the second table. Right joins will return all rows from the second table and then matching rows from the first. And finally, a full outer join. This returns all the rows from both the tables, including any non-matching values. It's important to note here that the term left table and right table in SQL joins just refers to the order in which you type it in to the join statement, left being the first and right being the next. Tutorial on W3 Schools, which is the same resource we're using for the editor, will explain joins in depth. You can use this for reference. But here, I've outlined it for you in the next few tabs. Let's take a look. The first one is inner join. This keyword selects all records that have matching values in both tables. It is the default join. So here, this is all the orders with customer information. You can see we select the orders table and the customers table, and within that orders table, we're selecting the order ID field, and within the customers table, the customer name field or custom name column. We'll select this from the orders database, and we're going to inner join customers. The next part will show where they reference each other. So customer ID in the orders is the same as customer ID in the customers. Let's run that. Next, left joins. This returns all records from the left table, table 1, and the matching records from table 2. Now 0 will be in place of non-matches. Let's take a look at all customers and any orders they may have. Again, beginning with a select statement, the customer name from the customers table, and the order ID from the orders table from customers. Left join orders, again, which values are similar. And here we'll just order it by the customer name. We can see now we have null values, 0 values, whereas previously we didn't. Next, right join. This returns all records, but the opposite to left join. Again, very similar to last time, except we'll be doing 3 separate fields: order ID, last name and first name of the employees, from the orders, so that'll be the leftmost column. Let's take a look. Again, null values will be accepted. Finally, a full outer join. This joins all regardless of any matches. Let's run it and take a quick look. A very similar structure to what we have used previously, with null values. Ordered. The full join returns records from both tables, whether they match or not. Here you can see they match. With the nulls in either column, they don't.